Imagine this. Deep underground, in one of the most advanced laboratories on the planet, a colossal machine accelerates tiny particles to nearly the speed of light. They smash together with unimaginable force, recreating conditions that existed moments after the Big Bang. Scientists are on a quest to unlock the deepest secrets of the universe. But lurking in the back of many minds is a thrilling, terrifying question. What happens if, in the process, we accidentally create a black hole? It sounds like science fiction, but this idea has been the source of heated debates, viral conspiracy theories, and countless sleepless nights for some people. But how close are we really to creating a black hole? And if we did, what would happen? First, it's important to understand what a black hole actually is. Picture a region of space where gravity is so strong, nothing, not even light, can escape its pull. Black holes are born when massive stars collapse under their own gravity or when two black holes merge. But some scientists propose that under extreme, controlled conditions like those inside particle accelerators, it's theoretically possible to create microscopic black holes, tiny versions so small they make atoms look gigantic. Now, these microscopic black holes are rooted in some of the wildest corners of modern physics ideas like string theory and the possibility of extra hidden dimensions curled up beyond the ones we experience. If extra dimensions are real, the amount of energy needed to create a black hole drops dramatically, maybe even within the range of current technology. And here's the fascinating part. Even if these tiny black holes popped into existence, they wouldn't devour the Earth. In fact, they'd vanish almost instantly. Thanks to a groundbreaking idea from Stephen Hawking called Hawking radiation, black holes emit particles and energy. The smaller the black hole, the faster it loses mass and disappears. For a microscopic black hole, that process happens in a fraction of a trillionth of a second. Blink and it's gone. If scientists ever detected Hawking radiation in a laboratory, it would be a monumental discovery, proof that black holes not only emit energy, but also a glimpse into the elusive link between quantum mechanics and general relativity, a unification of the laws governing the very small and the very large. But what about the Large Hadron Collider? That massive ring beneath the border of Switzerland and France is the most powerful particle accelerator ever built. It accelerates protons to nearly light speed and smashes them together with titanic energy. The kind of energy that could, just maybe, produce one of those microscopic black holes. The good news is, even if that happened, we'd all be perfectly safe. Independent safety reviews involving scientists from around the world have confirmed that the LHC poses no danger. Even nature itself backs them up. Cosmic rays particles from space hit Earth's atmosphere all the time with energies equal to or greater than those inside the LHC. If dangerous black holes could form that way, Earth would have been consumed long ago. But let's stretch our imaginations. What if, somehow, humanity created a black hole large enough to have serious consequences? To create even a modest black hole with the mass of, say, Mount Everest, you'd have to compress all that mass into a space smaller than an atom's nucleus. To make a stellar mass black hole, the kind that forms from collapsing stars, you'd need to squeeze several suns' worth of mass into an area about 30 kilometers wide. Our technology isn't remotely close to that. Not now. Not in the foreseeable future. But let's entertain the nightmare scenario. If a large black hole appeared near Earth, its immense gravity would wreak havoc. It would distort spacetime, destabilize Earth's orbit, and ultimately tear the planet apart, devouring everything in its path. But rest easy, that's the stuff of science fiction, not scientific reality. Interestingly, black holes aren't just cosmic threats, they could also be cosmic tools. Some physicists have speculated that, in the far future, we might be able to harness microscopic black holes as energy sources. Theoretically, a black hole the size of a proton could emit as much energy as several nuclear power plants, thanks to Hawking radiation. If we ever figured out how to contain one safely, it could revolutionize power generation or even propel spacecraft across the stars. Even more tantalizing is the idea of using black holes as natural laboratories. The extreme conditions near them could help scientists probe the deepest mysteries of physics, the true nature of space, time, dark matter, and dark energy. And while it sounds like pure fantasy, some theories even suggest that black holes or their hypothetical cousins, wormholes, could one day allow for faster-than-light travel, or maybe even time travel. The public fascination with black holes isn't new. Back in 2008, when the Large Hadron Collider was gearing up for its first run, panic swept across the internet. Lawsuits were filed to stop the LHC, with some people convinced it would create a black hole that would swallow the Earth. Experts debunked those fears, but the media frenzy ensured one thing: black holes became a viral sensation. They still dominate popular culture. YouTube channels like Veritasium, Kurzgesagt, and PBS Spacetime rack up millions of views diving into black hole mysteries. Films like Interstellar have brought black hole science to mainstream audiences, blending breathtaking visuals with surprisingly accurate physics. And who can forget the historic moment in 2019 when the Event Horizon telescope captured the first-ever image of a black hole? That glowing orange ring surrounding the black shadow of the Event Horizon became an iconic symbol of human curiosity and our ability to peer into the unknown. So, could we really create a black hole? In theory, yes, but only microscopic ones that vanish before they can cause any harm. The doomsday scenarios are just that, sensational stories with no scientific backing. Creating large, dangerous black holes requires cosmic-scale manipulation of matter and energy, something light years beyond what humanity can achieve. But the pursuit of understanding black holes continues to reshape science. These cosmic enigmas challenge our theories, fuel viral debates, and remind us how much we still have to learn about the universe. Someday, harnessing their power or unraveling their secrets might lead to technologies and discoveries beyond anything we can imagine. Until then, black holes remain both a warning and an irresistible source of awe and curiosity. If mind-blowing science, space mysteries, and future tech fascinate you, hit that like button, subscribe for more, and share this video with someone who loves the cosmos as much as you do.